Hello all, welcome back to another video. This video is for the students of class 12th. This is the second part of the video, Physics NCERT Solutions. In this video, I have included 3 questions from the chapter Electric Charges and Fields. That is question number 1.3, 1.4 and 1.5. The solutions of the questions 1.1 and 1.2 have been included in the previous video. The link of that video will be given in the description box. So let us start with the video. Here is question number 3. Check that the ratio ke square by Gmemp is dimensionless. Look up a table of physical constants and determine the value of this ratio. What does the ratio signify?
K E square upon G into mass of electron into mass of proton is given. The electrostatic force between two charges, that is F, is K into charge of electron into charge of proton divided by the distance square, which implies Ke square is equal to F into R square, which is unit of force is Newton and unit of R square, distance square, is meter square. Similarly, the gravitational force between two masses, that is F, is equal to G into ME MP, that is mass of electron into mass of proton divided by the distance square, which implies Gmemp is equal to F into R square, which is equal to Newton meter square, and unit of Ke square is Newton meter square, and also the unit of Gme, which is the denominator, Gmemp, is also Newton meter square. This Ke square is also Newton meter square. Gmemp is also Newton meter square. We can write this in dimensional formula. For Newton it is mL T minus 2, and for meter square L square. Similarly, for the denominator mL T minus 2 and L square, which is equal to M0 L0 T0. Therefore, Ke square by Gmemp is dimensionless.
What is the second part of the question? Look up a table of physical constants and determine the value of this ratio. What does the ratio signify? Let us see the solution for this.
Ke square upon Gmemp is equal to K value of K is 9 into 10 to the power of 9. This you have to remember. 9 into 10 to the power of 9, and the charge of electron is 1.6 into 10 to the power of minus 19, and the charge of proton is also the same, 1.6 into 10 to the power of minus 19. 1.6 into 10 to the power of minus 19. G, gravitational constant. Capital G is gravitational constant, which is 6.67 into 10 to the power of minus 11. And the mass of electron is 9.1 into 10 to the power of minus 31. And mass of proton is 1.67 into 10 to the power of minus 27. 1.67 into 10 to the power of minus 27. which is equal to, when you solve this, you will get 0.227 into 10 to the power of 40, which can be written as 2.27 into 10 to the power of 39. So this number, this 2.27 into 10 to the power of 39, this number signifies that the electrostatic force between an electron and a proton is 2.27 into 10 to the power of 39 times stronger than the gravitational force between them.
Here is the fourth question. Explain the meaning of the statement electric charge of a body is quantized. Why can one ignore quantization of electric charge when dealing with macroscopic, that is large scale charges? First of all, let us see the solution of the A part, that is explain the meaning of the statement electric charge of a body is quantized. A body acquires positive charge by losing electrons. A body acquires negative charge by gaining electrons. That is,
when an electron moves out of the body, it leaves a hole inside the body, and this hole is having a positive charge. This hole is having a positive charge. Therefore, a body acquires positive charge by losing electron. When a body gains electron, that means when the body gains an electron, the electron itself is having a negative charge. Therefore, a body acquires negative charge by gaining electrons. Therefore, Q is equal to plus or minus NE, where N is equal to 1, 2, 3, etc. and magnitude of charge, that is E, is equal to 1.6 into 10 to the power of minus 19 coulomb. 1.6 into 10 to the power of minus 19 coulomb. Therefore, the total charge of a body is an integral multiple of 1.6 into 10 to the power of minus 19 coulomb. Therefore, the total charge of a body is an integral multiple of 1.6 into 10 to the power of 19 coulomb. Either body can lose n number of electrons or it can gain n number of electrons, but never the fractional values. Either body can lose n number of electrons or it can gain n number of electrons, but never the fractional value. That is why the electric charge of a body is quantized. So that was the question, why the electric charge of the body is quantized. So this is the reason.
Why can one ignore quantization of electric charge when dealing with macroscopic, that is large scale charges? In the macroscopic scale, the magnitude of the charge is very large compared to charge of an electron. Hence, quantization of charge can be neglected. Here is the fifth question. When a glass rod is rubbed with a silk cloth, charges appear on both. A similar phenomenon is observed with many other pairs of bodies. Explain how this observation is consistent with the law of conservation of charge. Let us see the solution of this question. Consider two suitable material bodies A and B. Let that be as shown, A and B. Due to friction, if the body A loses electrons to body B, then A acquires positive charge and B acquires negative charge. So if A gives an electron to B, A acquires positive charge. What about B? B gains an electron, therefore B acquires negative charge. Therefore total charge is plus Ne minus Ne, which is equal to 0. Initially both are electrically neutral. After friction, total charge is plus Ne minus Ne, which is equal to 0. So this shows that the total charge is conserved. The remaining questions will be explained in the upcoming videos. Thanks for your time.